copper cable is that it is susceptible to attenuation, and attenuation is fluctuation in the network. So the longer the signal travel, the more it deteriorates. So that's why it is susceptible to attenuation. And all copper media must follow strict distance and limitation. So copper cannot go for a very, very long distance. Some would not, what would say that you cannot go more than 100 meters. And then it is also having these problems that it will encounter, EMIs and RFIs. So to encounter copper cables wrapped in shielding, so that's why some copper cables have we call the shielded twisted pair cables. And another major problem about copper cable is crosstalk. That is, we have color-coded wires inside one braid. So in that case, you have 8 wires, and all these wires are covered with sort of a plastic, so sort of a rubber. So if that rubber cuts out and the wires it's themselves touch each other, the spark that they cause is what is called the crosstalk. And when this happens, your cable is bad. So you have to either cancel the entire cable, or if you can spot where the spark is coming from, you cut that area and so throw it out. But to be on the other safer side, just cancel the entire cable and then crimp a new cable. There are 3 main types of copper media that is used in networking. We have shielded, unshielded, and we have quasi-shielded. This quasi-shielded, we're not using it nowadays. A lot of people use it on television systems where you're gonna have to have your TV connected to your satellite. And we have the unshielded twisted pair. This is cheap. It's for African lives, African people. It's very good. We have been using unshielded twisted pair. It is not durable, but shielded twisted pair cables are durable, and also they transfer data at a very, very fast speed. But we're gonna look at both of them. They're all good. We can use all of them, and that is how we have 4 pairs of wires inside each cable, and that's how it's all about. And they're color coded. So the UTP cable, that is the untwisted pair cabling, is the most common networking media that is used, and then we use RJ45 connectors to terminate this cable, and used for interconnecting network hosts with networking devices such as switches, routers, and so on and so forth. So it consists of 4 pairs of wires, like I said, that are color-coded wires that have been twisted together to help protect against signal interference from other wires. So the color codes aid in cable termination. They help you. So we're gonna do a practical on how to terminate these cables. So you guys can take notes, and we have still the twisted pair and the UTP. All of them does the same. They're all good. They're all the same. But the difference is that this one is durable because it has a lot of protections. The coaxial consists of copper conductor that is used to transmit the electrical signals, and a layer of flexible plastic insulation. So, but it's used mostly on television setups and so on and so forth. So the best safety precautions in configuring your your cables: make sure that you separate the data from the electrical cables. Make sure that you ground your cables properly, and make sure that all equipments are ground properly, and do inspections often to know what problems your network have along the way. So the properties of the UTP cable is that it consists of 4 pairs of color-coded copper wires that have been twisted together and then encased in a flexible plastic shield, or that is a sheet. So small size can be advantageous during installation. If you have a longer cables, you have problems. So it's important that you know how to terminate these cables. So cancellation is one major thing that will help you get rid of some of these problems that UTP cables have. So we have different standards or categories of UTP cable. The UTP cabling conform to the standards established by CCna and the EA. So the CCna is American standard, and the EA here is the European standard. They stipulate the cabling standards for line installation. So we have different kinds of UTP or STP cabling. We have Cat 3, Cat 5, Cat 5E, Cat 6, and Cat 6E. So we have Cat 3 that is used for telephone communication. They use RJ11 connectors for these ones, and here, because it normally comes with only a few wires, so sometimes they come with all the 4, all the 8, some that come with just basically the 4 wires. So those ones, RJ45, Cat 5 and Cat 5E, they're very good. They involve in data transfer, but Cat 5 support only 100 Mbps of data, but it's not recommended to use a Cat 5 for 1000 Mbps. If you want to go for 1000, you go for Cat 5E. For Cat 6, cabling is used for data transmission, but it goes for a very, very high speed, from 1000 to 10,000 gigabits data, but 10,000 is not recommended. If you want that, you go for Cat 6A. So guys, we have the UTP connectors, we have RJ45 connector, and you would have the wire coded code pin assignments, and that's peanuts for Ethernet cables. And this connector is the male component, and the socket will be the female component. And the essential that all copper media terminations be high quality to ensure optimum performance, because if they have problems, your network goes down. So to terminate cables, we'll do that in a practical format, and we have various types of cable termination. We have straight through, we have crossover, and we have rollover. To make it easy for you guys is that we crimp straight through cable for unlike devices like switch to router, router to switch, router to hop, those kind of things. You use that PC to a switch. Those ones, they are unlike devices, so you crimp straight through cable. That means one side of the cable crimped with T568A and the other side T568A, or you go with T568B on this side and T568B on the other side. So it has to be crimped the same way on both ends of the cable. That means straight through, and then you're gonna have to do that on devices that are unlike. For crossover, you guys can take note of this, because if we meet here, I am only going to do the practical. I will not do this explanation anymore. So you guys take your pen and then you write this thing. So we have the Ethernet crossover, that is one end would be T568A series and the other end of the wire of the cable would be T568B. So you use this crossover for live device, like when you're connecting a PC to PC, or you're connecting a router to router, or a PC direct to a router, or a switch to switch, or a hop to hop. This is when you are configuring or you're connecting live devices, you go with crossover cable. It's not common to use crossover cable if you're working in ISP or anywhere. Most of the time you'll be working with straight through, because you'll be connecting routers to switch or switch to PC, stuff like that. So good. And if you're done configuring or crimping your cable, it's important that you test your cable connectivity. Test whether the wire map is fine, whether the cable length is okay, whether the signal, there is any signal loss, and whether there is a crosstalk. Check all of these things using any of your testing tools. Alright guys, so we go to the properties of fiber optic. The fiber optic, we're not going to talk about it much because we don't have the termination tools right here, but it's important that we know that it's used basically for long distance communications or long distance cabling standards. So fiber optic cabling is now being used in 4 types of industries, and those are these ones: enterprise network, fiber to home, long haul networks, and submarine cable networks. So they transmit data over a longer distance and transmit signals with less attenuation, because they are not like copper. They're very, very good, and they can go for a very long distance, and they're immune to EMIs and RFIs, and they're used to interconnect network devices, and they're flexible but extremely thin. If I tell you that I find it very difficult to terminate a fiber optic wire or a fiber optic thin cable or wire inside, I find it difficult to even see this wire, because it's thin and some of them are silver. If you have light, you cannot see anything. So they're very, very difficult to work with. They're just as thin as, I can say, a thread. Thread is even bigger than them. They're like hair. You know, hair, how thin hair is. So bits are encoded on the fiber as light poles instead of electrical signals, and thus are some of the parts of the fiber optic cable. So we have different types of fiber optic connectors. So we have fiber optic connectors. We have different types. We have the straight tip. We have the subscriber connector. We have the lumen connector, and the duplex multi-mode or multi-LC connectors. So any of these depends on how you do in your configuration. Most of the time, I see this in many places. That's the subscriber connectors. If you are working at ISPs, at the ISP end, you have this type of connector. Okay. All right, guys. So we move forward. Those are the common patch cords for fiber optics, and the fiber patch cords are required for interconnecting infrastructure devices. The yellow jacket is for single mode fiber optics, and the orange one, that is the aqua, or you can call it as the aqua, for multiple fiber cables. And the fiber cables should be protected with small plastic cap when not in use. That's why they all have those ones. So to test it is very important. It also have what we call the optical time domain reflectometer. It's an important tool that you can use to test your cable connectivity. Alright, so that's the fiber optic and copper wires differences. So you can go online and search for the difference between fiber optic and copper cable, because this is a video and just have to make it short and fast so it doesn't affect you. So we have wireless. Wireless media carry electromagnetic signals that represent the binary digits of data. So that's about wireless. So what wireless have some concerns, areas of concern, that is coverage area. If you move from a wireless for a distance, every wall, every how do you call it, physical barrier can affect the signal of, or it can hinder the signal strength of a wireless connection. So also interference are also areas of concern, and it can be disrupted. Such common devices as fluorescent lights, microwave ovens, and other wireless communications can all affect the wireless signal. Security is also a concern, because device can connect at any time. Not authorized for access to the network can gain access to the transmission and all that. Shared medium, because it is shared, any device can connect and many devices can connect flexibly, so it makes the network very, very slow as many devices connect. So these are some areas of concern when you are working with wireless. So but we'll come to all that later on. So those are the wireless types. We have the Wi-Fi standard 802.11. We have Bluetooth. We have WiMAX, which provide a very, very, very long distance wireless access. That is WiMAX, and that is the worldwide interoperability for microwave access. So, like in this country, we have QCell that is offering this type of wireless access, and it is using IEEE 802.16. You may be asking an exam. So wireless uses this. This is some of another characteristic of wireless. That is the CSMA CA. That is a collision avoidance. That is the carrier sense multiple access collision avoidance. This is what wireless access devices use, because they cannot deal with collisions, so therefore they avoid collisions at all costs. But wired connections use CSMA CD collision detection. They can detect collision and then they try to isolate those collisions. So wireless LAN requires this network device as an access point and a wireless NIC adapters. So if you want to connect to this wireless access point, your device must have a NIC and then you must have a access point. Alright, so we go to the last bit here. That is the data link protocols. Alright, so the data link is layer 2 of the OSI layer, and it prepares network data for physical network, and it transmits what we call frames. Alright, so the physical layer has what we call the MAC address information. What it does is it transmits data, and it is the physical address that carries the frames across the link. So the data link is divided into two sub layers. That is a logical link control